Hi everyone, welcome you all to the Brilliant Group of Institution. Here we are going to discuss the most important NCERT question from the chapter Amines, the organic chapter Amines for your term 2 examination. Alright, so we can enter into the question number 1. This is a NCERT in-text question. Classify the following amine as primary, secondary and tertiary. You know, it's very simple to identify a primary amine. And we have secondary amine, then tertiary amine. How we can identify the given amine is primary, secondary or tertiary? Dear all, if the compound contain NH2 group, you can call it's a primary amine. If it contains secondary in the sense if it contain NH group, it's called secondary amine. If it contain just a nitrogen and 3 bonds, that's called tertiary amine. In another sense, you know, NH2 group where nitrogen 1 bond is the one of the valence is free now. If it is connected to 1 carbon, it's called primary. Here 2 valencies are free, 2 carbons can be connected, it's called secondary. Here 3 carbons can be connected, it's called tertiary amine. Clear? So, simple way we can identify which is a primary, secondary or tertiary amine. Dear all, if the compound contain NH2 group, it's primary, NH group secondary, N it's called tertiary. Let's go for the question. Here we have in the first question, it's contain NH2 group, therefore it is a primary amine, right? Primary amine. And what about here? Nitrogen. This nitrogen connected to CH3 and 2 CH3 are there and 1 more carbon. See, total 3 carbon, this nitrogen connected. So, just nitrogen is there. It is like tertiary amine. What about third one? Which means NH2, that's primary amine. And the fourth compound just contain NH group. NH means secondary amine. Clear everyone? So, this is the first type of question. As per the beginning part of the chapter, mostly they will ask you the IUPAC nomenclature of primary, secondary, tertiary, even aliphatic and aromatic amine. The next thing is how to identify the primary, secondary, tertiary amine. This is the first type of or the basic type of question from the beginning part of the chapter amines. Let's go for the question number 2. Write the structures of different isomeric amines corresponding to the molecular formula C4H11N. Alright, C4H11N. This is the compound given. We can write the maximum possible structures of which one? This amines. Already they given. You want to write this isomers. You know what is an isomer? Isomers is the compounds having same molecular formula but they're having different structures, right? So here C4H11N, total there are 4 carbon atoms. So 4 carbon contain amines, maybe primary, secondary, tertiary, all are possible. Let's see the maximum possible one. So let me write the first compound in the formula. Total there are 4 carbon atoms, right? 4 carbon atoms. So I can place it like CNH2. Is it possible? See dear all, CH3, CH2, 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 NH2. Total there are 4 carbon with an amine. It's a primary amine, right? Yes, because it contains NH2 group. Now what we can do there? Within 4 carbon, any other structure possible? Yes, I can place the NH2 group into the second position. So write CH3, CH2, CH, NH2, CH3. Another primary amine. Then, any other primary amines are possible? Just try. We can change the number of carbon atom, right? The carbon chains, I can change it like CH3, CH, CH3, CH2, NH2. Dear all of you, see this one? It's a primary amine, but the carbon chains are different. Alright. And the fourth compound, any other primary amine is possible? Yes, one more is possible. How to draw that? CH3. Alright, it's just like a, you know, this is a tertiary group with an amine, right? This is all our primary amine because they contain NH2 groups. Alright. Now we can go for secondary amines are possible or not. Secondary amines with the same formula. You can check it, the formula is correct or not. Okay, C4H11N. Yes, all are. How we can draw a secondary amine? CH3, CH2, CH2, NHCH3. Possible, right? Its NH group is secondary amine. Now I can draw the another one, CH3. I can place NH2 in the center. CH3, CH2, NH, CH2, CH3. All right, this is also possible. Any other secondary amine? Yes, the seventh one, CH3, CH, CH3. Here NH, CH3. Possible, right? All of you. CH3, CH, CH3, NH, CH3. And one more is possible. You can write. So secondary maximum, the three of them possible. Then we can check it. A tertiary is possible or not. Of course, it's possible. CH3, N, CH3, CH2, CH3. Total 4 carbon, nitrogen at the center. All right. This is the maximum structures or 8 structures which is possible for the given compound C4H11N. First question, write their IUPAC name of all the isomers. Okay, what is IUPAC name, dear all? Here total we have 4 carbons. So select the longest chain, 4 carbon, and amine is the functional group. It should get the lowest number. So number 1. So I can say the name of the compound as butane. Total there are 4 amines, 4 carbons, right? So butane 1 amine, butane 1 amine, or you can say butanamine, right? Butane 1 amine. Similarly, what is the name of this compound? Here amine should get lowest number. So 1, 2, 3, 4. We can say that butane 2 amine. Yes or no? Butane 2 amine. All right. What is the name of this compound? Select the longest chain. Don't deviate from the IUPAC nomenclature rules. Okay. Select the longest chain. This is the longest chain. So this is a branch. Amine is the major functional group. So it should get lowest number 1, 2, 3. Second position, you have a methyl group. So the name is 2-methyl. Total there are 3 carbon atoms. So propan, where is the position of amine? 1 amine. All of you once again. 2-methyl, propan, 1 amine. Alright. What about the last compound? Here the last compound, select the longest chain. Either you can select 1, 2, 3, 1, 2, 3. All are same. So let me take, this is the longest chain. This is the branch. Amine is on the second position. So 1, 2, 3. Second position methyl group. So we can say 2-methyl, 2-methyl. Alright. 2-methyl, propan, 2-amine. 2-methyl, propan, 2-amine. Possible or not? All of you. Propan, 2-amine. 2-methyl, propan, 2-amine. Alright. So IUPAC nomenclature from any of the organic chapter is very important, because if you know the IUPAC nomenclature, then only distinguishing test, conversion question, everything will be easy. Now, compound number 5, it's a secondary amine, right? Because it contains NH group. Okay, how to write the name of a secondary amine, dear all of you? The NH group, left side how many carbon? 3 carbon, right side only 1 carbon. So your parent chain is on left side, right? So let me take your parent chain here, and this is the methyl group. So here nitrogen connected to a methyl group, so we can say N-methyl, all right, N-methyl. Total 3 carbon contain amine, we can call propanamine. Propanamine, right? This is the parent chain, 1, 2, 3. Here nitrogen contain a methyl group, so N-methyl, propan, 1 amine or propanamine. Alright, what about this compound? This is the amine position. Left side 2 carbon, right side 2 carbon. So any one of them, you can take it as a the parent chain, remaining all are branch. What is this branch now? Ethyl group. Yes or no? Ethyl group. So N-ethyl, we can say the name of the compound as N-ethyl ethanamine, right? N-ethyl ethanamine or ethan 1 amine. Okay, N-ethyl ethanamine. What about the 7th compound? This is the one we have, and which is the parent chain, dear all. Here the parent chain is this one, right? This is the longest chain left side, and this is the branch, methyl group. So N-methyl, so we can say N-methyl, all right, N-methyl. Dear all, N-methyl, propan, here amine is present on the second position. So propan 2 amine, N-methyl, propan 2 amine is the IUPAC name. N-methyl, propan 2 amine. What about 8th compound? Here nitrogen contain 1 one carbon, here 2 carbon. So 2 carbon, let me take it as the parent chain. So these all are branches. Here nitrogen contain 2 methyl group, yes or no? So what we can say, N-dimethyl. N-dimethyl, because nitrogen contain 2 methyl group. Even in organic chemistry, normal hydrocarbons, when you are naming, if the 2 methyl groups are on second carbon atom, you will write 2,2-dimethyl, right? Similarly, here nitrogen contain 2 methyl group, therefore N-dimethyl. Total 2 carbon contain amine. What is that? Ethanamine. Ethanamine. All right. So that's very essential to know the IUPAC nomenclature of each of the organic compounds. So N-dimethyl ethanamine is the IUPAC name. Hope you clear? Let me go to the question number 3. Write the chemical equation for the following reaction. Question number 1. Reaction of ethanolic ammonia with C2H5Cl. Dear students, C2H5Cl, what is that? C2H5Cl, ethyl chloride, right? Ethyl chloride. You know, it's a alkyl halide. When a alkyl halide treated with ammonia, you know, the process is called ammonolysis. Ammonolysis. That is the second preparation of amines from the NCERT textbook. So when ethyl chloride you treated with ammonia, is a simple method. We can say that this hydrogen from ammonia, one hydrogen, and this chlorine is removed as HCl, and you will get the compound C2H5NH2. Very simple procedure. From your haloalkane, take the halogen, and from ammonia, take one hydrogen, and HCl is removed, and C2H5NH2. Product is ready, no? Now, the main problem for the ammonolysis, or you may study what is the main demerit of ammonolysis. Dear all, ammonolysis we can use to prepare. Normally it is used to prepare amines, but the problem you can't stop with. You know this, when a haloalkane treated with ammonia, you're getting a primary amine now, right? NH2 group is there, but it won't stop. It won't stop with the primary amine, dear all of you. It will continue the reaction, because in your reacting mixture, so many alkyl halide will be there. The formed amine, again it will react with the same haloalkane, which is the haloalkane C2H5Cl. What will happen? Again one hydrogen and chlorine removed as HCl, and C2H5 will come to nitrogen. You will get C2H5N C2H5. Dear student, now it is a secondary amine. It won't stop with the secondary amine. It will again continue the reaction. It will again react with the C2H5Cl, the same haloalkane. This hydrogen and chlorine removed as HCl, and this ethyl group will come to nitrogen. You will get C2H5 and C2H5, C2H5, and nitrogen contain. You know, always nitrogen contain the lone pair here. Now it is a tertiary. So you may think it will stop with a tertiary. No dear, it will again react. It will again react. It will again react with a C2H5Cl. So you may think how it can react, because there is no hydrogen on nitrogen to remove with the chlorine. But you know, nitrogen contain a lone pair, right? By using this lone pair, here all our lone pair is there, okay? Nitrogen contain lone pair. Dear all, by using this lone pair, it will attack your C2H5 and it will remove the chlorine. So you will get C2H5 and C2H5, C2H5, here also C2H5. Here nitrogen donated a lone pair, so it will get a positive charge, and this chlorine is removing as Cl minus. Here nitrogen connected to 4 carbon atom, it is called quaternary. Quaternary. This is primary, secondary, tertiary. This is called quaternary ammonium salt. So quaternary salt will form. So ammonolysis, the main demerit is, if they given a haloalkane with ammonia up to quaternary, the reaction will continue. If they not specified the amount of reactants. What is that point? All of you should look into the second question. In the second question, they are starting the same thing, ammonolysis of benzyl chloride. What is benzyl chloride? You know, benzene with the CH2Cl is called benzyl chloride. Ammonolysis of benzyl chloride and reaction of amines so formed. So let me make the amine which is going to form first. So let us treat it with ammonia. When you treated this benzyl chloride with ammonia, same thing will happen. This is a haloalkane and this hydrogen chlorine removed as HCl. So you will get CH2, to which what will come? NH2, right? NH2, benzyl amine. It's a primary amine. Oh, of course, initially you will get a primary amine. Okay. So product form. Amines are formed with 2 moles of CH3Cl. Dear student, here they specified the number of alkyl halide. 2 moles. So you cannot take, here we took maximum the alkyl halide, but here they specified what is the number of alkyl halide you have to consider. 2 moles of CH3Cl. Okay. So let me take one CH3Cl. What will happen, dear all? This is an amine, right? Amine treated with the haloalkane, the hydrogen chlorine removed as HCl, and you will get benzene with the CH2, NH is there, to which the alkyl group will attack. Now it is a secondary amine, alright? And what happened when you treated with the 1 more CH3Cl? Because they said you can use 2 moles of CH3Cl. This hydrogen and chlorine removed, and you will get benzene with CH2, NCH3 and CH3. Now it is a tertiary amine. If 1 more CH3Cl is there, it can undergo again reaction, it will give quaternary. But we can't write because they specified the amount of CH3Cl. Clear everyone? So if during ammonolysis, if they didn't specify the amount of alkyl halide, how much it's reacting, you can carry out the reaction up to quaternary. But if they specified the number of the alkyl halide, you should stop with that. Clear all of you? Next question. Write a chemical equation for the following conversion. Question number 1 is given CH3CH2Cl. It's nothing but ethyl chloride. We have to convert into CH3, CH2, CH2, NH2, propanamine. Alright. Dear all of you, in this kind of question, it's very careful. Total how many carbons you have in the reactant side? You can see 1 and 2. Only 2 carbon, right? Here you have 2 carbon in the reactant side, but how many carbon in the final product? There are 3 carbon, right? There are 3 carbon. So we need a step up method. What? We need a step up method. We want to increase the number of 1 carbon. Mostly to increase the number of carbon, we need to introduce a cyanide group. One of you, here 2 carbon in your reactant and 3 carbon in your product. If you want to increase the number of carbon by 1, mostly we are using cyanide. We want to get cyanide group. You know how we can convert a halogen into cyanide? When you treat it with the alcoholic KCN, KCl will eliminate, cyanide will substitute. So you will get CH3, CH2, CN. Please observe, dear student. Now how many carbon in your this product? 1, 2, 3. Yes, we did. Now the next purpose, how we can convert cyanide into amine. You may study how to convert cyanide into amine. By reduction. What is the reducing agent we are using? Hydrogen in presence of nickel. Or we can use sodium amalgam with the ethanol. Right? Hydrogen in presence of nickel or sodium amalgam means NaHG, sodium amalgam with ethanol. We can convert Cn into CH2NH2. You know, reduction mean addition of hydrogen, right? Yes, to the carbon they added hydrogen, to the nitrogen they added hydrogen. Right, you will get amine. The same thing, the same procedure we are going to do for the second question. In the second question, they given benzene, you know, C6H5 phenyl group with the CH2Cl. What is this compound is called benzyl. This benzene with the CH2 is called benzyl chloride. Benzyl chloride we have to convert into, you know, okay, C6H5, CH2, CH2, NH2. Dear all, what is the main difference? What is the main difference? Here, this compound which contain benzene ring, phenyl ring with 1 carbon, but here benzene ring with 2 carbon. Here also we need step up method. What is step up method? Just to bring your cyanide, means alcoholic KCN. When you treated, KCl eliminate, cyanide group will attack. So you will get benzyl group with a cyanide group. Now carbon numbers are equal. Now we can convert cyanide into amine. How it is that? Hydrogen in presence of nickel. That's it. Clear everyone? Next question. Write the structure and IUPAC name of, question number 1, the amide which gives propanamine by Hoffmann bromamide reaction. This is one of the most expecting question for your examination, that is Hoffmann bromamide degradation reaction. Very important the naming reaction for the preparation of amines, primary amines. Dear all, what is happening in a Hoffmann bromamide reaction? You know, the starting material, so let me take a general equation first of all. In Hoffmann bromamide reaction, your starting material is an amide. You know, RCONH2 is called what? The amide. Okay, amide. You know, Hoffmann bromamide, the name itself giving you some idea. Bromamide. So, bromine and amide is the reacting one. So, amide is ready. Let me take bromine. This reaction is carried out in presence of a base, for example, NaOH. And one alkali, NaOH. What happened when amide treated with the bromine and alkali NaOH? Dear student, it's very easy to write the product, dear all. From your amide, remove the CO group, your amine is ready. From the amide, you remove the CO group, the carbonyl group, your amine is ready. What is remaining here? RNH2, that is your amine. Okay, RNH2 plus. You know, byproducts are common always if you are using NaOH. The byproducts are, you know, sodium bromine, sodium bromide, and you will get sodium carbonate, Na2CO3 along with the water. This is the byproduct. So, dear all, this is a conversion of amide into amine. What is the major speciality of the Hoffmann bromamide reaction? You know, Hoffmann bromamide reaction, during Hoffmann bromamide reaction, if your amide contain 2 carbon, your amine contain 1 carbon. That is called Hoffmann bromamide degradation. 1 carbon degrading, 1 carbon we are removing. So, the amine formed which contain 1 carbon less compared to the amide which is used. Alright, for example, let us use the same example. Question number 1 they given. The amide which gives propanamine by Hoffmann. So, your amine form is propanamine. What is propanamine? Propanamine is CH3, CH2, CH2, NH2. This is called propanamine. 3 carbon contain amine. Okay. If you want to prepare this amine, which amide we have to use? Dear all, the amide, if it contain 2 carbon, your amine contain 1 carbon. Means amide 2, amine 1. Your amine always contain 1 carbon less. Here amine, they given 3 carbon. So, your amide should contain how many carbon? 4 carbon. So, what is that amide? CH3, CH2, CH2, alright. Now, dear all, which CO group you are removing? CONH2 group, right? So, near the NH2 group, there is actually a CO group, then NH2. This one you have to react it. This is the amide. So, the same procedure I am following. If you remove the CO group, your amine is ready. This is the 4 carbon contain amide. What is the name of that compound? Butanamide. Alright? Butanamide. Easy reaction. Now, we can go for the second question. Reverse question. Which amine produced by the Hoffmann degradation of benzamide? Here your amide is already given. Benzamide. What is benzamide? Benzene with CONH2. This is called benzamide. When benzamide undergo Hoffmann bromamide degradation reaction, do the same procedure just to remove the CO group. If you remove the CO group, what is left in the system? Benzene and NH2. What is benzene with NH2, dear all of you? Aniline, right? Your product is what? Aniline. You know, aniline is also called benzene with amine. Benzenamine. Aniline or benzenamine is the product. So, Hoffmann bromamide degradation is a very, very important question for your exam. Next one. How will you convert? Question number 1. Benzene into aniline. Benzene into aniline. You know, aniline means benzene with NH2. Okay, dear all. Directly, we cannot add we cannot substitute a NH2 group on benzene ring. Let me do the procedure once again. All of you please practice it. I can do nitration first of all. You know, nitration means treating with a concentrated nitric acid and concentrated sulfuric acid. all right, you will get nitrobenzene. So the first process you have to do nitration. Now we studied how we can convert nitro group into amine. How we can convert nitro group into amine. That is the first preparation of amine you may studied in NCERT textbook. 3 ways are there, right? 3 reagents can be used. Any one is enough just to understand. What are the 3 reagents normally we are using to convert a nitro group into amine? This is actually reduction. From the nitro group, you want to remove oxygen and you want to add hydrogen, correct? So what are the reagents? You may study either hydrogen in presence of palladium in an ethanol medium. Reduction, addition of hydrogen with a palladium, or we are using metal with acid, right? What are the metal? We are using iron with HCl, or we can use tin and HCl. Okay, any one of them is fine when you're writing examination. So first, to bring an NH2 group on benzene ring, first do nitration, you will get nitrobenzene. Nitrobenzene on reduction, you will get aniline. Second question, the same thing. What is the second question? Benzene into, starting material again benzene. Benzene into N-dimethylaniline. Alright, N-dimethylaniline. What is N-dimethylaniline? You know, this is a benzene with a nitrogen aniline group. N-dimethyl, because nitrogen contain 2 methyl group. How it is possible? Anyway, we need a nitrogen on benzene ring. Means the previous step we have to carry out once again, right? So let me do the reaction once again. First I am doing nitration. Concentrated HNO3 and concentrated H2SO4. We will get nitrobenzene. Okay. Now I want to reduce nitro group into amine. We can use hydrogen in presence of palladium. I will get amine, right? Nitro group converted to amine. Okay, done. Nitrogen we fix it. How we can add a alkyl group? Alkyl group. Dear student, if you want alkyl group, we can add alkyl halide. Means if you want CH3 group, right? So let me take CH3Cl, methyl chloride. Here a hydrogen and chlorine removed as HCl. So you will get the compound benzene with, from NH2 already one hydrogen gone. So NH, this CH3 group will attack. So one CH3 group, you got it. But you want 2 CH3, right? Add one more CH3Cl. Let us add one more CH3Cl. Here the hydrogen and chlorine removed. So the CH3 group will attack on nitrogen. Yes, we will get our compound N-dimethylaniline. Clear all of you? Next question. The third question we can go for that. The third question is chlorine. Okay. CH2 4 time. CH2, then chlorine into hexane 1,6-diamine. What is this compound hexane 1,6-diamine? Hex mean total 6 carbon, right? 1, 2, 3, 4, 5, 6. Okay. 1 and 6. This is the first carbon. There is an amine. Second sixth carbon. There is an amine. Okay. This is the compound. Dear all of you, check it very carefully. 1, 2, 3, 4, 5, 6 and first and sixth position there are 2 amine group, alright. Here very careful, in your reactant side, how many carbons are there total? This is chlorine and total 4 carbon. In your product side, total how many carbon? 6 carbon. So we have to make the step up method, correct. Here we can see that there are 2 chlorine at the end, right. So we can add, dear student, 2 alcoholic KCN. I told you step up method mean we have to bring cyanide. So 1 chlorine, if you remove, 1 cyanide can be added. Remaining chlorine, 1 more cyanide. So 2 cyanide when you added instead of the chlorine, the compound becomes 6 carbon. So I can write here, it will be CN. Then we have CH2, 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 CH2. From where this one? You know, CH2 4 time in the bracket. This chlorine also we replaced by cyanide. Okay. Now how many carbon in your product? 1, 2, 3, 4, 5, 6. Yes or no? Now the next process. How we can convert cyanide into amine? By reduction. Right? Hydrogen in presence of nickel can be the best one. So this cyanide on reduction you will get CH2NH2. This cyanide on reduction you will get CH2NH2. The center 4 carbons already there. So always if you need a increase in number of carbon in your reactant, the product side, so mainly you have to use the step up method. Try to bring a cyanide group. Then it is easy.
Brilliant Qatar, your trusted coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.